this substitution with indefinite integral. If g prime is a continuous function on the interval AB, and f is the continuous function on the range of g of x equal u, then the integral from a to b of the composite function f of g of x times g prime of x dx is equal to the integral from g of a to g of b of f of u du equal to f of u plus c, where f of u equal to f of g of x, the composite function. Now, let's prove this theorem. Let's see how this works. Let f, g, u, and f be specified in the theorem. Then the derivative of capital F of g of x is equal to f prime of g of x times g prime of x by the chain rule. Okay, and so I can go ahead and say, well, I will let u equal g of x. Then f of g of x is equal f of u, yeah? This means d du of f of u is equal to f prime of u, right? So let's integrate both sides of the equation. The integral from d of d du f of u equal to the integral of f prime of u du. Now, the integral of d du f of u by the fundamental theorem of calculus is equal to f of u, or just by the integration is equal to f of u plus c, equal to the integral of f prime of u du, and it's equal to the integral of f of u du. So this meant we proved the substitution rule. So here we can see that, so here this meant that the integral of f of g of x times g prime of x dx is equal to the integral of f of u du. Let's see how we can put that into practice. Problem solving strategy, integration by substitution. First, we look carefully at the integrand and expression g of x within the integrand to set equal to u. Let's select g of x so that g prime is also the part of the integrand, and you see this more when you start doing this type of problem more. Substitute u equal to g of x and then take derivative both sides, du equal g prime of x dx into the integral. We should now be able to evaluate the integral with respect to u. If the integral cannot be evaluated, we need to go back and select a different expression to use at u. Now, sometimes we need to do more than one substitution to get our answer. So let's try this. Okay. So here in this first problem, we're told that given this integral, and we're told that we want to use u equal to negative 5x squared minus 1. Okay. So now that we have u equal negative 5x squared plus 1, would mean du is equal to negative 15x to the 4 dx. And let's look to our integral. Here this is negative 15x to the 4 dx. I then can rewrite this integral. Now become u times du. This equal to 1/2 u squared plus c. Okay, so this is 1/2 negative 3x to the fifth minus 1 square plus c. In the next case, we were told that u equals secant of 4x. Okay, so du, derivative of secant, equal to secant tangent, and we have a chain rule, so 4 secant of 4x times tangent of 4x dx. Let's take a look to see whether we get this in our integral. We get 4 secant 4x tangent 4x dx. I just realized I make a typo here. This should say 4 secant square of 4x tangent of 4x. Okay, so let's rewrite this. So really you get 4 secant of 4x tangent of 4x. Now because it's a secant square, we have another secant of 4x dx. So now here we can see this part is u, right? And this part is du, right? So this meant this become, by substitution, this become u du. Okay. And so that is 1 over 2 u square plus c. That is 1 over 2 secant the 4x square plus c, where c is a constant. Let's see if we can evaluate each definite integral. In this case, we were not told what is our u and what is our, we was not told what is u, so we need to figure out what is u ourselves. So in this case, I will let u equal to x to the third plus x. Then du equal 3x squared plus 1 dx. Substitute into the integral, I get u to the fifth du is equal now 1/6 u to the sixth plus c, and that is x to the third plus x all together to the sixth plus c. In the next problem, I let u equal to 2x plus 1. So then du equal 2 dx. Now, we don't have a 2 dx. So the next thing we do is to solve for dx. So dx equal to 1/2 du. Yes. Okay. I can now rewrite my integral as the integral of the square root of u times 1/2 du. So I bring the 1/2 up front. So this is 1/2 the integral of u to the negative to the 1/2 du. So we have 1/2. So 1/2 plus 1, that is 3/2. So 1 divided by 3/2. So that multiplied by 2/3. U to the 3/2 plus c. This is 1/3 u to the 3/2 plus c. And this is 1/3 times 2x plus 1 to 3 over 2 plus c. Okay. So what should I let to be u in this case? Well, let's say if I let u equal to tangent of x, then du, derivative of tangent, equal to secant squared of x, right? So that didn't really help me. So that does not really help me. Du equals derivative of tangent of x equals secant squared of x dx. Let's see how this is going to work. I can see that I have a secant squared of x dx here. That is my du. So I can rewrite my integral. That is 18 u squared du divide by 2 plus u cubed. And I will try to do the integral, take the integral of this. Now, I don't know how to take this integral. So what I need to do is I need to figure out a u that would simplify my function to something that is workable with. So this doesn't work. So let's try with a different one. So let's say, go ahead and let u equal to tangent cubed of x. So then we will see that, well, du equal to 1/3 tangent squared of x times secant squared of x dx. Oh, hey, look like I have it here, right? I have it here. Okay. But here I have an 18 tangent squared of x, secant squared of x dx. Well, I can solve a tangent square, tangent squared of x, secant squared of x dx. This is telling me that I have 3 du equal tangent squared of x times secant squared of x dx. Let's just substitute this into our integral. So now I have sit du divided by 2 plus u square. And there's supposed to be a square here. Okay. So it's a typo in this function. This is supposed to be a square here. Okay. So now that I have a square there, well, the next thing, well, how am I supposed to take the integral when I have a square in the denominator? I don't know. So I'm going to do another u substitution. So this part, again, I'll go ahead and let u equal to 2 plus u. Excuse me, let w. So dw equal du. Okay, so let's substitute this into our integral. So now what do we have? We have sit dw divided by w square. Okay, this is something I totally can integrate, right? So, integrating this, I get here? I get negative sit over w plus c. All right. So w equal to 2 plus u. So negative sit over 2 plus u plus c. And w equal to tangent cube. So this is negative sit over 2 plus tangent cubed of x plus c. All right. Let's take a look at the next problem. Okay. So how we solve this. So let's start with let u equal to 2x plus 1. Du equal to 2 dx. Wait, but now we have an extra x here. And so what do we need to do? So one way of going around this is we can solve for x in terms of u. So this means I can say that, okay, if u equal to 2x plus 1, this means x is equal to u minus 1 divided by 2. And I will use that to substitute into my integral. So then here I have the integral. I put the 1/2 up front. 1/2 u minus 1 times u du. And remember right here, there's a 2 here. So this is another 1/2 du equal to dx. So then we have another 1/2. So the whole thing become 1/4 the integral from u square minus u du So 1/4 times, this is 1/3 u to the third minus 1/2 u squared plus c. So this is 1/12. U is 2x plus 1 to the third minus 1/2 u squared is 2x plus 1 squared plus c. Well, substitution with the definite integral. So what's different now is that after we finish doing the integration, we will then evaluate this at the two endpoints. So let's take a look at this. I'll go ahead and let u equal to x squared plus x plus 1 du equal to 2x plus 1. Now, we have to remember the upper and lower limit of your integrand are in terms of x. So I'll go ahead and solve for it to see what is it in terms of u. Okay, so the upper limit, u equal to 4 squared plus 4 plus 1. 4 squared is 16 plus 4 is 20 plus 1 is 21. The lower limit, u equal to 1 squared plus 1 plus 1. This is 3. So then I'll change my integrand from 1 to 4. Now become from 3 to 21 because this is in terms of u. Of 1 over u du. The integral of 1 over u equal to ln of u. Evaluate this from 3 to 21. That is ln of 21 minus ln of 3. The next one, we look at the integral from negative pi to pi, the sine of x times sine of cosine of x dx. Okay, so let u equal cosine of x. Du equal negative sine of x dx. So negative du equals sine of x dx. And again, we need to change the upper and the lower limit. The upper limit, u equal to cosine of pi, or cosine of pi equal negative 1. U equal cosine of negative pi. Cosine of negative pi also equal to negative 1. Okay, so now let's take a look. Now this integral become the integral from negative 1 to negative 1 of sine of u du negative. But remember, recall that the integral from a to a of f of x dx is equal to 0, right? So again, this equal to 0. The next case, I'll go ahead and let u equal 1 plus t to the third du equal 3t squared dt. So 1/3 du equal t squared dt. The upper limit, u equal to 1 plus 1 to the third. That is 2. The lower limit, u equal 1 plus 0 to the third. That is 1. The integral become 1 to 2 of 1. So put the 1/3 out front. 1/3 du divided by root of t. So then what do we have? 1/3 integral from 1 to 2, and this is what? Negative root, that is root t, that is t to the negative 1/2. dt. So this is 1/3 times 2t to the 1/2. Evaluate from 1 to 2. That is 2/3 root 2 minus 2/3. Definite integral of even and odd function. So if the function is even, so let's just take a look at this explanation. Say, recall x squared, the function y equal x squared is even. Yeah. And let's say this is our negative a, and this is a. Because this function is even, the area underneath the curve from negative a to 0 and from a to 0 is equal to each other, right? So then if the function is even, then the total area will be just twice of the half of that integral. Whereas if a function is odd, and we call the function odd, let's see, x to the third. X to the third, here we have negative a, and here we have a. Part of this area is negative, and this area is positive. Now, the positive area and the negative area is equal to each other in this case, and so the integral from negative a to a cancel each other out. That's how you get 0. Determine whether the function is odd or even, then evaluate the integral in the given interval. So let's take a look at the first one. F of x equal to sine of x divided by root of 1 plus x squared plus x to the 4th. Okay, so to determine whether the function is even or odd, we substitute x equal to negative x into the function and see what happens. F of negative x equals sine of negative x divided by root of 1 plus negative x squared plus negative x to the 4th. So this is negative sine of x divided by root of 1 plus x squared plus x to the 4th. This is equal to negative f of x. This implies f of x is an odd function. Okay, because f of x is odd and we want to evaluate this integral from negative pi to pi, this meant negative pi to pi integral of f of x dx is equal to 0. In the next case, we want to evaluate the integral of x to the 4th minus 2x squared and plus 0 from the integral from negative 3 to 3. Again, f of negative x is equal to negative x to the 4 minus 2 times negative x squared. This means we have what, x to the 4 minus 2x squared. So this equal to f of x. So then f of x is even. This meant that the integral from negative 3 to 3 of f of x dx is the same as twice the integral from 0 to 3 of f of x dx. And that is so 1/5 x to the 5th minus 2/3 x to the 3rd. Evaluate from 0 to 3. So 3 to the 5th is 125 over 5 minus 2/3 times 27 And this is 25 minus 54 over 3. So 75 over 3 minus 54 over 3. This is 21 over 3 equal to 7.